Pete, were you telling yourself to go home? I don't know. I don't understand what was going on in the pre-chat before the stream started. Pete says, oh no, not again. And then go home, Pete, you're drunk. Oh, I am. Okay. I don't know. I don't know what's going on. Hello to everybody. Happy Sunday, or if you are in a time zone that is way, way, way back, living in the past, stop living in the past, then happy Saturday evening, or midnight, or whatever it happens to be. I'm just trying to load the TTS right now, and it doesn't seem to be loading. It just says loading. Hang on, I will show you. I will give you the evidence. Here we go. Here we go. Here's the evidence. This is TTS. Loading. And I don't get nothing. Oh well. I'm dying. I'm dying even before the stream starts. Waiting on 2 AM load shedding, says Mitchell. No. Yes, happy time zones, everyone, says Pete. Hard refresh. Okay, hard refresh. Let's see what happens if I do that. No, nothing happened. All right, I'm going to open a new browser window with the same URL, and the same thing happens. Sorry, Mitchell. I did a library upgrade, so most likely cause, says Mitchell. That's cool. No problem. No problem. I just need to say hello to everybody. Oh, before I before I start saying hello to people, I must first DIY. Oh no, we're not going to get the audio. DIY just did a super chat. Later, if we get if we get TTS working, we'll have to do the audio on the super chat. Okay, try incognito or clear session data. Let's see if that works. The problem is I'm not going to remember what my authentication stuff is. No. So this is in an incognito session. I just loaded that URL and it just says loading. No audio this time. Oh, the auth bug is back. Oh, could be. Okay. Yes, dislike and unsubscribe. Get onto that, everybody. Oh, sorry. A moment ago, I was trying to do something. I will do this. I've got to do this first. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Good morning, everybody, again. Properly, officially now. All right, who do we have here? Amanda, of course. Good morning, Amanda, and thank you for promoting the stream yesterday. Just about most weeks when I post the stream, yeah, when I schedule the stream so it appears on YouTube and then it pops up as a notification in Discord, Amanda jumps on it and promotes it on Facebook. Even when I don't. So my my promotional assistant. Also, some call it fun. Good morning. And who else is here? DIY in the Ghetto. Stephen W. Jordan. Tech Nebulous. Stephen George. Russell Rennie. Michael Wires. Crispian is here. Who else do we have in the chat? 50 Hertz. Welcome, 50 Hertz. Pete, of course. Jordan. Rod Whitby is here. Good morning, Rod. Skimming down. Imogen is here. Welcome, Imi. Delane, David C. Guru of Nothing. I think I am here, therefore I am. Yes, Grant. That's right. Mitchell. Sorry, I'm just scanning through. Oh, Henrik. I saw Henrik posted and then retracted the message, and I don't know what the message was. Who else? Gerald42. Oh, okay. Gerald42 says, a quick hello and goodbye. I was dog sitting. My buddy and his wife are home now and I don't want to be rude. Go on. Go on, be rude. Any mules? Good morning. And Johnny Begdale, David Howes. And I think that's it. Oh, okay. Mitchell says the bug is fixed now. So let's see what happens when I try to load this. I'll do a shift reload, see if this works. No. 401, not authorized. Oh, it looks like something is happening. Okay. you could see my username then, but you couldn't see the password. So it is fine. All right, here we go. And Crispian says, boo. It'll catch up. We will get the audio coming up soon. Maybe. Maybe. Maybe I should reload at this point. All right. While that is doing something. Yeah. Okay. Now, does anybody remember this spreadsheet? Yeah, Stephen, you did see my password. So, yes, this spreadsheet, you may remember it from that dim, dark, distant day 7 days ago, as we were sitting here in the same place, same bat time, same bat channel, but 7 days prior. Project Dopamine. Let's finish stuff. Or at least make progress. Now just got too much voltage. Hang on, I'm just still trying to load the TTS. So people are trying to use TTS and it's not going to work yet. Maybe it'll catch up. Password management. Let's not get into that. Let's not chase that squirrel. All right, so this spreadsheet in the pre-stream chat, where are we? I'm going to scroll back. Amanda said, I don't have time to finish a project when I keep starting 10 more for each one I'm working on. Yeah, that is the problem. And Some Call It Fun asked, is it that each idea spawns a bunch of others? And Michael said, projects are never complete, they just enter the maintenance phase. Amanda said, I never get to the maintenance phase in the first place. Yeah. Oh, and then Some Call It Fun said, I hate to admit it, but usually after the grand planning phase, I lose interest in the actual building of most projects, but I'm purely a hobbyist, so nothing is on the line. I still enjoyed it. Okay, so this, I think, partly gets to the crux of it, because, you know, I'm going to screw up this saying, but it's something like the first 80% of the project takes 80% of the time, and then the last 20% of the project takes the other 80% of the time. I don't know. I think I screwed that up, but there's some saying that's vaguely like that. And the fun part is all up front. It's when you're starting a project and all of the possibilities are open to you, and your expectations of thinking forward to how you're going to execute the project, your mental projection of how you are going to execute it is perfection. You have this goal in mind. You know what it is you want to achieve. And so what you visualize is that desired outcome. And inevitably, so what you do not do is visualize a flawed outcome. You're always visualizing the ideal outcome. It is what you want without flaws. And inevitably there are flaws. In everything we do, things don't quite work out. If you're making something physical, maybe you won't cut something that's perfectly straight. so it doesn't fit perfectly. Or if you're writing code, you structure it in a way that then makes it difficult to achieve certain things, or it's just not elegant because you do like a quick and dirty, oh, I'll show you some quick and dirty code a bit later on perhaps. Yeah, you do a quick and dirty thing thinking you'll come back and you just made yourself some tech debt, and then you're down the track, you're 80% of the way through the project, now you need to make some changes, but you've already got the embodiment of how you solved part of the problem early on. So now you're frustrated because you no longer have this blank slate in front of you. You don't have the picture of perfection. You're dealing with the reality of a partial implementation, and it can be frustrating. So, yeah, as Amanda and Some Call It Fun were talking about in the pre-stream chat, it's that initial phase that is the fun bit, and I find that is my problem. I start something because an idea jumps into my head. I have a goal or something that I want to achieve, and so I start, and then I don't quite get to the finish line. Although, as Michael pointed out, there is no real finish line projects. If you get a project to the point where it is functional, it's probably not finished. It's just in maintenance phase. And if you do not apply a maintenance phase and keep working on it, things go wrong. Technology moves on. Libraries get updated and now your code is broken, or whatever reason. So there is inevitably some kind of a maintenance phase as projects progress, as they go more from a blank slate and a concept in your head to a physical or virtual, in the case of code, thing that is an embodiment of that idea. Mitchell says, actually, libraries got updated and this code is now broken. Yes, Mitchell with the text-to-speech is facing exactly this. So this is the text-to-speech project that we use on this stream is Mitchell's personal thing that he started doing just as a fun thing, like oh, that sounds like I could do something that takes the chat and processes it but from the YouTube API, and then we can generate text to speech, and then do other things. That would be really cool. And now all of a sudden, Mitchell has this thing which is in maintenance. You could say it's in maintenance mode because it's been working for quite a while now. It does all the necessary things, but now a library has changed and we get this. So now Mitchell has to go and do work when, in theory, having achieved something that works, it should have just stayed like that and the world would have been good. But no, a maintenance phase, unfortunately, is necessary. So when you do a fun little thing that is just like a quick and dirty little project, you have effectively made a rod for your own back, and something that you need to maintain if you want it to keep working and be relevant into the future. Oh, James is here as well. Good morning, James. Always remember the difference between strategy and tactics. Producing a beta product is fine. Perfect, maybe too good. Yeah, that is true. Hang on, I'm going to stick this up here. Get the chat up on the screen. Yeah. Yes. So, yeah, you do have to remember your goals. And maybe you just want to do something as a quick short-term thing. You don't necessarily want a well-supported product that is going to last indefinitely. You just want to solve some problem, like a throwaway tool or project, or a bit of code that achieves something, like processes some data and you're not going to need to process that data again. Johnny says, I like the MVP concept, minimum viable product. Get it out the door before you start adding features. Yes, that's exactly right. And the tension can be when you have, in a commercial environment in particular, where you have pressure from sales and marketing and customers who are wanting you to add things to suit their particular requirements. And okay, so Mitchell pointed out, however, to expand on your I speak real good words. Okay, I've got to get words out. I've got to try to get Mitchell's words out. Here we go. Mitchell said, however, to expand on your explanation, the platform on the higher level now, which runs multiple front ends for other projects, is what broke. The actual YouTube assistant doesn't need to change. So, yeah, it does make updates and maintenance easier since one place for multiple things with minimal breaking, but lots of regex fixes at the moment. Ooh, yeah, regex. For those of you who have never played around with regular expressions, consider yourself lucky. Regular expressions are brain-bending and incredibly powerful. Yes. Regex. I used to do quite a bit of regex back in the Perl days. Perl. Who remembers Perl? Practical extraction and reporting language. Yeah, it used to be used for all the things that these days you'd use Python for. Oh, and James pointed out, just remember MVP is really a proof of concept, not a real product, despite what the sales team may want. Yeah. Now, getting back to the point of this. The whole point of this, of Project Dopamine, is finishing stuff. Henrik said, so what project are we going to fix today? I think I missed it. What we are going to do today is air quality sensor. But I did mention before some nasty throwaway codes. So how about we take a little deviation from that. Hang on, I am just going to try to bring up a terminal. Is a terminal what I want? Yes, I think a terminal is what I want. Where? I can't even remember where I put this. Where did I put this code? Oh, I remember where I put it. I've just got to get into this directory. It's in Dropbox. I think it's in this location. Maybe. Oh no, it's not there. This is really exciting, isn't it? In OpenPnP jobs. Oh no, in test. Okay, here we go. I'm going to show you what I've been messing around with. And I'll show you my ridiculously bad Python. Because I don't do Python. It's just, I thought it would be a thing to, yeah, well, I always want to try new things. Okay, what have we got? All right, what we have here is a failure to communicate. I don't know if I really want to go into this in a huge amount of detail. I'm just going to give you a very quick skim through of this, because then people can start thinking about all the ways that I've screwed it up and give me suggestions. So what this does, if I have a look at this now, ignore orange, that does not exist. We have 3 chunks of XML here. This is for OpenPnP. We have a job, which is the high-level definition of what we want to assemble on a pick-and-place machine. The job contains a panel, and the panel defines the relationship of multiple boards. And then we have a board. So this is like an example structure. Sometimes you can have a job just with a board as well, without a panel. But I'm doing some messing around, and I'll show you the result of what it does, and then I'll show you the code so that you can all laugh at me. All right, so if I do split OpenPnP job and I give it vrep job, so I am passing it an argument which is the path to a job file for OpenPnP. In fact, what I'll do is show you the job file first. Vrep job. So it's just a chunk of XML, and as you can see, it specifies a panel. So we've got an object here, which is the panel location and the file name, and then it's got some metadata, I suppose you would call it, which is data about the contents of the boards which are contained within the panel, and I won't get into all of that. That's just how it tracks what parts it has already placed. So if we come back to here and run, oh, that's funny. I can't run it on this computer. I don't, yeah, well, I set up a VN and then, screw it. I don't want to actually get totally sidetracked into this. This was not my intention anyway. So yeah, I need the beautiful soup. I need beautiful soup installed. So let's have a look at split, and what it does is looks for an OpenPnP job file and bails if it can't find it. Then it loads the configuration files for 2 pick-and-place machines. So in this case, it's loading the backups, which are stored in Dropbox. It's not loading the actual live configs, because I was using this just to mess around on my laptop while I was at everything open. So it reads the config and loads the XML, parses it using Beautiful Soup, and then it finds all of the feeders that are enabled on that machine and builds up a list of all the part IDs. So at the end of this, it has 2 lists of parts, one for machine 1, one for machine 2, and yes, I know this needs to be refactored so that we can have arbitrary numbers of machines. That's for the future. Then it opens the job file, and it comes up with 2 new job file names. So it's going to make new job files for the machines and makes copies of them. And it has to be a deep copy because we don't just want a pointer. We want to make an actual copy of that data. So we end up with 2 XML structures in memory for the 2 machines. Then we parse it to find the panel file, open it, we define 2 new panel files, once again we deep copy. Then we open the board files based on the panel, so it's finding that in the XML. Then looks for if it exists and explodes and sets the house on fire. If it doesn't, then defines new board files. Okay, so this is where it's actually starting to get to doing something useful. That was all precursor setup stuff. So what it does here is goes through and updates the file so that they are pointing to the new locations, and it goes through each of the placements and it turns them off if they were not configured for that machine. So we end up with a board file for machine 1 and a board file for machine 2, and these two have only the parts enabled for that machine. Then it writes out the board files, writes out the panel files, writes out the job files. Okay, that was a pretty poor explanation, but the end result of all of that, what actually happens is, if it had run, we would end up, instead of having a job file, a panel file, and a board file, we would have two job files, two panel files, two board files. And essentially it splits the job into two, and one half of the job goes onto the first pick and place machine, the second half of the job goes onto the second pick and place machine. And then they can just be loaded by the machines and run. So that is on, where are we? Somewhere in here. OpenPnP cluster. Write out target job files. That's actually working now. So I can update this. We can get a little bit of a dopamine hit because that is done. What it needs to do next, the next thing is bypass panel file if the board exists in the job. That'll do. Okay, a little bit of a little bit of progress. Outside the box asked, does that work with your parts optimization protocol? Oh, yes, that's what this is all about. James Derrick said, pauses to read shallow versus deep copy PyDocs. Yeah, so the different, it's really just if you take a variable, whatever it is, doesn't matter what form it is, and you have another variable and you make it equal to the first one, by default, Python does a copy by reference. So if you change the value of the first variable, the second one automatically changes because it's not its own separate thing. It is just a pointer to the original variable. And so what I needed to do was make an actual duplicate of the thing, of the XML, so that I could have two copies of it and edit them independently. Michael says, pointers, I see core dumps. Yeah. All right. So I won't bother explaining this now because I want to get on to the air quality sensor before I get to 20 minutes from the end of the stream and haven't even begun the actual topic, which would be typical for me. Well, while Fusion is opening, yeah, I don't know why I tell you about this stuff, but I don't know if you can tell wearing through my glasses, but if you look at it feels good to take the glasses off. You might notice this eye is not the same as this eye. Yesterday I managed to slow down someone's fist with my face. I attacked their fist with my face. So it's kind of partly swollen shut, and you can see it's starting to change color. But I got his fist real good. Yeah, that wasn't the only time I got clocked. Where are we? Back here. I caught some really good body shots yesterday too, and one that I am surprised did not break my nose. It was like not that one, like the one on, not the one on here. There was another one as well that caught me because my training partner was going for an uppercut exactly as I was covered, and I started to descend to go in for a body shot, and as I descended my arms came apart right as his uppercut came through, and it it caught me pretty well. But yeah, that's not why that's not why my eye looks like that. Pete says, "Oh, you broke the hand with your eye socket." Yes, that's my cunning plan. Johnny says, I created an array overflow the other day. Turns out ESP's time.weekday uses the values 1 to 7, not 0 to 6. Really? Oh. Yeah. I think I've come across that before. And I think no, I don't remember. I have spent way too much time screwing around with date formatting and time zones and all of that stuff for, yeah, Crispian says, always use the right tool for the job. The right tool for the job, yeah. Using my face to slow down. His fist was not a good tool for the job. Problem is that there's really not much I can do against Shane. Firstly, he is really good. And secondly, he's about 6'5" and massively outreaches me. I can't get close to him without being like right in the danger zone. So there's no way I can get near his face, just no chance without being clobbered. Basically all I can do is either keep backing up and kick, go for the legs, which is my usual plan, or cover up and go for body shots, go in low, because it's the only way I can get to him. Yeah. He's a great guy to train with, though. Okay, so I've got, where are we? I've got Fusion open, and I'm looking for air quality sensor. Here we go. There was a major new release of Fusion during the, hang on, I've got to get this down where I can see it. Yeah, there was a major new release of Fusion this week, and it seems to have changed a bit about the way it does its, like if I, not from there, Superhouse projects. Yeah, it seems to have changed some of its project management stuff, and also it's turned electronic stuff into a first-class citizen, because by default when you set up Fusion it assumes that you're doing a 3D CAD project, like an MCAD project. But this time it came up with the setup dialog and said, how should we optimize your workspace? Should it be optimized for electronics or MCAD or whatever the other options are? I don't even know all the things that Fusion can do. So I said optimize for electronics. And the result is that now whenever I open it, it comes up with this. So yeah, it's all oriented around electronics. It's a project, it's an electronics project by default with PCBs and schematics and stuff. So if I want to do an MCAD project, I have to specifically do a new, just new design. Now, what I want to do to start with is have a look at what I did previously. And why isn't it here? Am I going to have to go searching? I think I am. Somewhere in here it should be enclosures. I wonder if it wasn't under AQS, because I know I've done enclosures for previous air quality sensors. But it was a long time ago. The AQS was, it's an old project. Sea squirrel. You're not meant to see that. That's another squirrel. No, that's a secret project that I haven't mentioned before. Try refresh, says Mitchell. Ah, okay. Here we go. Here we go. And, oh, maybe. Let's see. Let's see. Do we get it? Shift reload. And back into here. Yes, Mitchell, you fixed it. You are the regex master. I shall come to you in future for all my regular expression requirements. Now, who have we got here so I can mark off? Mitchell. Outside the box. Pete. This is how I see who has spoken up in the chat. Michael Wise, James Derrick, Henrik, Johnny Begdal, some call it fun. Me. It puts me in because I talk. Stephen W. Jordan, Stephen David, Sharky, Tech Nebulous, Russell, 50 Hertz. I don't think I said hello to 50 Hertz yet. Rod is here, Imi, The Lane, Grant is here, Gerald, Any Mules, David Howes, Paul. I hadn't said hello to you yet, Paul. So, hello. Welcome. I don't know if it's going to catch up on audio that was... it has everything, but it hasn't event triggered. Andrew. But it doesn't look like it's going to catch up and play the audio. Yeah, it won't do audio. Thanks, Mitchell.
Pete said, Steve and Steph proof of life.
Maybe. Maybe. Might make you wait. Gotta keep you guessing. Are they still here? Jordan says, I think you'll need to tell it to play each one. No, unfortunately, I don't think I can. It hasn't... Oh, hang on. No. It hasn't processed the ones that were already, like, the backlogged ones. So... Ah, yes. James with the regular expressions. Substitute bug for solution global. Yeah. For those of you who let's zoom right in. Here we go. For those of you who don't know what regular expressions are, this is a simple example. This is a search regex. So S is for search. The first argument, what this is doing, the caret symbol is tying to the start of a string. The $ is tying to the end of a string. So those are anchors. It's searching for bug. So what this will do is find any reference to, whoops, get off there, to bug. It will then replace it, get off, with solution. And the G means global. And I noticed, James, that you are living dangerously there because you haven't added a confirm flag on your regex. It's just going to do it globally. Oh, Johnny says, Autodesk forced me to update Fusion 360. Now it crashes every time I exit it. Yeah, that's funny. Well, it's not funny, it's sad. It happens to me too. Like, you'll be using Fusion 360, happily using it, works fine, close your projects, quit Fusion 360, boom, crashes. It crashes on exit. It doesn't like the fact that you're leaving it, Johnny. Michael Wire says, G equals just ship it. Yeah. Yeah, Jordan says, at least it's on exit and not on open. Yeah, there used to be a bug in Fusion where it would crash on open if there was some corruption in one of the environmental files. And, oh, see the little meteor on the right of the message. You can't really play the special sounds though. Oh, I'm just getting messages from Mitchell via back channel. Yeah, and the only way to get around it was to clean the environment before you launched it, and then you'd lose all your preferences, and oh, that was a pain. So, what are we doing here today? I want to make an enclosure to fit this. What have we got? Just checking grids in millimeter, yes. We've got a hole here which is located at 5541 and 55.3. So I think these are M3 holes. What are they? There's 2.2 millimeter. Okay, so they're clearance holes for an M2 bolt. This whole thing is quite small. We've got the S3 module there. S3 Vroom S3, whatever, whichever. And on the other side we've got the screen. Or is it this side? No, it's the other side. That's right. This is the side with the parts on it. And then the laser scattering sensor is on the other side. Oh, excuse me. On the other side of the PCB. And then the screen is sandwiched onto that. So the actual structure, if we open it up, Johnny says, I hate M2.5 screws, do 3 millimeter. These are actually for little self-tappers. They're not really properly they're not M series machine screws, like they're not metric machine screws. So yeah, so this is more of what it looks like. And we'll just rotate it. Because we're looking at it from the back, the light source in Fusion is from the other side. So we're on the shadow side. We're on the dark side of the moon at the moment. The big blue box there is the particulate matter sensor. Then we've got the screen sitting in front of it. We've got the PCB at the back with the S3. There is the mode button on the top right, which is designed to protrude through the case. There is the reset button, which is designed just to be pressable with like a pin or something. So in the enclosure, I will need to leave a little hole just for something to poke through and push the reset button. But the mode button will need to come through. We've got the USB-C connection sticking out the back. It's that horrible, horrible vertical mount USB-C socket. These things are terrible. I do not like. So, because they are impossible to rework. Look where those pins are. Look at them, hiding in their little prison cell with these bars in front, designed to prevent you from getting a soldering iron or anything else useful in there to be able to rework those pins. So if you have a solder bridge, and I can't remember the pitch on these pins, but I think it's like 0.65 millimeter or something. Yeah, if you get a bridge on those pins, good luck, buddy. Good luck getting in there. You're gonna be out of luck. Yeah, let's make a box. Let's make a box. But what I wanted to do was, I wanted to look at the design for the previous enclosures because yeah, Johnny says, well, I have a 0% success of USB-C reflow. Yeah, USB-C sockets suck. They are terrible to work with. Pete says, my face just crashed. Oh, my face crashed a long time ago, Pete. It is seriously defective. It needs to be thrown in the trash. James said, M3 to M5 hex head are lovely in AliExpress sorter boxes for random projects. Yeah, I've got M2, 2.5, 3, 4, and 5 in just about every length, like 2 millimeter increment lengths. So I've got 4 millimeter, 6, 8, 10, 12, 14, 16, 18, 20, like, and some bigger sizes in every one of those. I've got a set of drawers with all the different sizes. And for the most part, I have them in both hex head with the little round head on them, and countersunk, which the countersunk ones generally, but not always, are Phillips head. Sometimes they are also hex, but with a smaller hex than the standard thing. Anyway, over here in the box, get rid of that. We have my notes for the project. Slightly out of focus, but that's only because the camera is focused for being on the bench, not being up here. I'm going to pull up, because I can't find the project, so I'm going to pull up some older enclosures just to see what the hell I did last time and to get a clue for what I can do this time. I probably should zoom that camera out a little bit, but we can probably see enough. Is that the one that matches that? Looks like it might be. Oh, here's another one. See, I've done all sorts of iterations of this in the past. So, where are we at? Okay, this one. This is version 4. This is the most recent hardware. And right now, this one is running Austin's firmware. So, what I'm thinking about, okay, I'm gonna grab myself a USB-C cable and power this up. Not that we need to, but just because it's fun. All right, power that up. You can see we've got the power LED come on. The screen should come on the front in a minute, and then there it goes. Superhouse AQS, it's got a little red signal strength meter, and now it's gone green. And it's now saying 18.3, 18.4. It is not 18 point whatever degrees in here. This must be still warming up. That temperature is going to go up. It's saying 89.2% relative humidity. That's going to fall because it needs to run the heater in the sensor. The values we get out of this environmental sensor are going to be bogus for a couple of minutes at least, because it needs to run its little preheater. CO2e, B, VOC values it doesn't have yet. It'll take a while to get that. It's got PM values. PM 1.0 is 3, PM 2.5 is 3, PM 10 is 4. So it's getting some values from the particulate matter sensor at least. Where am I? Stream still working? Yes, good. Temperature is going up. Relative humidity is coming down as the sensor is preheating itself and calibrating. All right, so this is what we need to stick inside an enclosure. So we just need a little box. Let's make one. This one was moderately successful, I think. This design worked okay. That might be for a different iteration. Yeah, this one, no, that one definitely doesn't fit. These two don't match, or do they? Oops. I think they were meant to match. Nope, they don't quite match. I should have written versions or something into these. What I'm just trying to do is find a matching pair so I can do, well, this doesn't actually match. This is not a matching pair, but it's close enough to show you the concept. The idea is there should be a screen on the front of this. In fact, I might have a screen. I do have a screen. If I plug this screen in here, like that, then this goes over the top here like that. It doesn't properly close because this is a mismatched version. It's a couple of different versions of the hardware and the enclosure. But you can see here that we have the screen visible through the front. We have, on this case, the mode button was on the back. On the new one, the mode button is on the top and the reset button is on the top. Also, USB-C was coming out the side. Now we have USB-C coming out the back. And on this one, the PCB was this funny shape that came down into these feet. But on the new one, the PCB is just a rectangle. Because I Okay, so why do we have this cavity? The reason for this is for access to the particulate matter sensor. It has these vents on the bottom. There's an intake vent and an exhaust vent. It's a little fan in there, so it blows. So air gets drawn in through here, goes through the laser scattering sensor, gets blown out through here. There is also this little thing here, which is a BME 680 environmental sensor, which is doing the temperature and humidity and volatile organic compounds and all of that sort of malarkey. So they need to be exposed to the air, and that is why I designed it with this cavity on the bottom, this opening, and with little feet that stick down, so that if you were sitting it on a table or a shelf, imagine that you're looking straight down now, but imagine this was horizontal and this was sitting on a shelf coming out from the wall. It'll just sit on it like that, and this space underneath gives free air flow to the sensors. So that's what I want to achieve. So my plan for this is to make a box. Even though this is a rectangular device now, I want to make a box that is this sort of shape, but it can be smaller, because as you can see, this is physically quite a bit smaller than the old PCBs. These early ones were, look at that, look how much wider it is. That's because of the LEDs on the side. I had RGB LEDs down the sides to make the whole case glow different colors depending on the quality of the air. Now with Austin's firmware, we've got the colored border here on the display. So you can glance at the display and you can see, yes, it's good, we're not dying today. At least not from poor quality air. So I need to design something. How am I going to begin? It is so long since doing this that I'm kinda lost where to start. Where to start? I think where I need to start is with this, some calipers, although I should have all the dimensions in CAD anyway, but I don't trust CAD. I always like to measure stuff. Yeah, I'm at this point of trying to figure out the best strategy for modeling this.
Outside the box said, measure first.
Yep, measure first. And then write the number down correctly. That's the second thing. It doesn't matter if you measure accurately if you don't record it. What I'm trying to figure out is, alright, think, talk, explain. I need to create a model or a sketch as a starting point for this in Fusion. What should that sketch be? And this is the foundation that everything else is built from. There are a few different ways that you could model this. One is I could do a sketch which is at the point of the PCB. So it would be, imagine you've taken a slice through the PCB, or at the front or back face would be more accurate. Say you've taken a slice at the front face of the PCB. No, we'll go back face. And drawing a sketch which includes things like the hole locations and the outline, so that we can then extrude it in two directions, towards the back for the back half of the enclosure, towards the front for the front half of the enclosure, and we can create two bodies. Because what I need to do is create a front and a back body. The other way, there are other ways you could do this. You could start with your primary sketch being on the top face and then work down from there, model it that way. But I think the logical thing to do is start with the model and the first sketch of the model being based on the rear face of the PCB, which is where that is going to sit, like that. Except this will be the equivalent of, but I also have to think about, should I center it on this, or can I slide this in? I've got to think about how to get this into the case as well. I'm gonna unplug this now. Because if, for example, in the enclosure I have a hole in the end here for the button and I have a slot down here for the USB-C connector, to put it in I would need to angle it and slide it in, get the button through, and then drop the USB-C connector into the hole. I think that's quite acceptable. I think it'll work. But you have to think about the angles here. So if you consider, oh, here we go. If we consider from a cross-section point of view, that going in means that this is going to potentially intersect with or foul things down here. So you've got to think about the angle as it goes in. I think it will work because we can get that button in while the PCB at the top edge is very close to this face. You see how here it has lowered the PCB by 4 millimeters, which offsets everything in that direction. But if that goes through a hole, the PCB ends up very close there, which means there's no offset on the bottom, or very little offset. So the slot just needs to accommodate the angle in there. So yes, I know I'm talking about something very, very specific here, but to me this is key, and it's thinking ahead to how this is going to be assembled. It's going to be two halves that snap together or screw together, but I still need to think about how to get this structure into the rear part of the case. The other way to do it, which is also quite legitimate, is to do it, so okay, with these ones, I don't know if these match, close enough. The seam is halfway along, and in fact I am totally rethinking this now. Whew. This is why it pays to talk this through and think about this. What if, instead of making it two halves of a clamshell like this, it was an enclosure with a back plate? I think that might work better. So instead of putting the...
Some call it fun said, that switch sticks out. Can it go on the other side of the board?
With difficulty, because there's not a lot of room here. It physically wouldn't fit. I'd have to make it... I could make the PCB very slightly larger. Oh, I don't know. I'm probably right. I probably could. Some call it fun. I think you're right. That switch could be assembled on this side of the board, and it would still work electrically. It would be exactly the same. Just put it in on the other side. However, the USB-C socket sticks out the back, which means that the enclosure has to come to that sort of point anyway. But it could come, yeah, you've got me thinking now as well. It might be better with that towards the front instead of towards the back. Ooh. I am now very tempted to unsolder this switch and put it in on the other side, which would put it, at the moment it is offset towards the back of the enclosure quite significantly. If the enclosure is, say, 30 millimeters or 28 millimeters deep, it's going to be right towards the back. But if it was here, it would be towards the front. I think I like that. And I think the body, if you look at it vertically through there, this back part of the body needs to clear the top part of the sensor. And it would just.
Some call it fun said, I guess as long as you have standoffs in the case, it's good for this version.
Yeah, what I was planning to do was not use separate standoffs, but mold them into the enclosure like this. So this is what you'd mean by a standoff, I guess. And then, so this is the back part of the case. It's got these little shelves that the PCB can sit on. And then on the front, it has this leg that protrudes down, pushes onto the front of the PCB, and then a screw goes in from the back through the PCB and into the front, and that's what holds it all together. So now what I'm thinking is, I think I might model this from the front and make an enclosure that, instead of being two almost symmetrical halves with a split in the middle, make it so that it's a full enclosure with a back panel. So this can go into the enclosure and then be fully enclosed, and then the back panel just covers it. What that would do is move the seam. Instead of having a seam around the body there, the seam would be at the back, just where the back cover comes on. So I think I will do it that way. All right. I'm going to start. How should I start? How should I start? I think I'm going to start by putting the geometry of the PCB in place, just so that I have a starting point, and then work from there and treat it as if the front face is my reference geometry. And then when it gets 3D printed, it'll get printed face down, so that this face is the nice surface. This will be the surface that's against the build platform. Okay, I think that is enough blathering around. I think I need to start actually sketching something. And how thick did I make this? 1.25. Yeah, 1.2. I would have made the walls of this 1.2 millimeters, because that geometry works nicely with a 0.4 millimeter nozzle on a 3D printer. Yeah, so I'm pretty sure everything here will be 1.2 millimeters. It just works nicely for the slicer in terms of doing a triple perimeter, for example. If we stuck this under the microscope, we would see that there is like if you make it 1.2 millimeters thick on the walls, it gets printed as a solid essentially. And anyway, it's just optimizing the geometry for that purpose. So let's start thinking about drink. All right, I've been missing the chat. It'd fall on its front. Say that switch sticks out. It'd fall on its front. No, it wouldn't. I think it would work. I like the idea of a straight, not 90-degree switch. PCB just drops in the same plane as the PCB. So the issue is whether that switch is going to be used. Pete says, new drinking game. Drink when John actually starts doing something. The game is to guess how sober you'll be at the end of the stream. You will be sober. No, thinking about stuff is as important as doing the stuff. Maybe. All right, I'm going to do... No, I don't want to do new electronics design. I need to specifically do new design and do a sketch, and I'm going to make a... What are our geometry? What's our geometry here? Let's have a look at the PCB. It is 58 by 44 millimeters. So let's go 58 by 44. So 44, 58. That is the dimensions of the PCB that we have to make fit inside this thing. And I'm just wondering if I should do... No. Do I want clearance? How accurate is this PCB? Because there's always variation in the actual manufacturing of PCBs. 58... It's pretty well spot on, 58 millimeters by 40. Wow, JLC have outdone themselves. It's to within you know, it's within 1/10 of a millimeter accurate in the geometry, which is nice. But I also need to make it so that it's not too tight. I'm not going to make this, when you 3D print, typically walls and things end up intruding into voids. Physical space comes into the void, which means that you need to allow for that slightly and have some offsets. The chair's not sliding properly. What I should have done is made that construction lines, because this is just the reference of the geometry for the PCB, which is just for my own entertainment, I suppose you could say. So what I want to do, I could, so many ways I could do this. All right, I'm going to add a bit of a safety margin. So this is 58. If I add 0.4 of a millimeter on each side, so 0.8. So if I make that 44.8 by 58.8, yeah, and at this point I should be, I know I should be parameterizing all of this, but no. Okay, so then, then what am I going to do? Then I'm going to do another one, which is, yeah, I really shouldn't be doing it this way. This is like a crude way of modeling. So I want to add 2.4, and the reason I chose 0.4 as the clearance offset is because it makes this maths easy, and still watch me screw it up. So I want 44.8 becomes 45, becomes 47. So I want 47 by 50, what was that? 58. 44.8, where is that one? Okay, so that is 58.8, 59, so 61 should give me a 1.2 millimeter shell. Oh, Stephen says standard tolerance is 0.2 millimeter for JLC. Yeah, okay, so now I'm going to add myself some little, what am I going to do? What am I going to do? Let's just stick a reference line along here somewhere. Kind of arbitrary, and I'll anchor this off the corner, bring it in. No, I don't want that construction. I want that to be, let's make it 10 millimeters wide. I'm just making stuff up here. It's just on the basis of what does it look like. It's all about aesthetics. So we'll give it those little feet, and then we're going to dimension this off the center. 35. How about we make it 32 to bring it up, and then I want that collinear. Why? Oh, can't see all my tools. Collinear with that, and I want that collinear with that. Right. What have we got now from there to there? That is 55.5 millimeters. Yeah, that is all right. Now, did I make? Yes, I made that slightly rounded. It's all about how it looks, says David. Yeah, none of this function BS. Yeah, don't care about the function. And what size did I make these legs on the old one? 16 millimeters. Okay. maybe that needs to be about 14, because this whole enclosure is a bit smaller. We may have to adjust this later anyway, because, oops, because we need space. Oh, actually, how big do I need the gap to be under the thing? See, this really is not a spectator sport. This is not the sort of stuff that you want to sit around and watch someone do. 40 millimeters. All right. What is the gap? It is going to be way less than 40, but if we do there to there, what is that? 33. Okay, so I do need to decrease this. Let's make that, we'll take it back to 10 and back to 10. Now what have we got in between the feet? 41 millimeters. Close enough. Okay. So then I'm going to need, actually let's put a construction line right down the center here and lock it, because I'm going to use that as a guideline for offsetting various other things. So now we need to put a, no, I don't want that to be construction. Now we need to put a hole in for the display, and that is going to be 24 millimeters square, I believe. 24 by 24, so we go 24, 24, bada boom. Now it's got to be centered, but I don't have the vertical position set yet. So what I'm going to do is measure the offset from...
Amanda Thompson said, John, I am enjoying your fusion logic.
Thanks, Amanda. So now I need to figure out the offset. Where is the center of the screen relative to the top of the PCB? And this is where the model kind of lets me down, and I have to just resort to measuring, because I don't have an accurate model for exactly where the viewable area is on here, and the top of these two bits of PCB should be aligned. If this was actually stuck on there properly, that should be a straight line if I get the camera aligned properly there. So what I need to do is figure out the center of the viewable area with an offset relative to the top of the PCB here, and then I can offset that cutout to match. So let's do this. What? Ah, it's the wrong one. Look at this. It's micro B. Where is... No wonder the USB-C connector won't go into it. Okay. Let's try again. This is the version 3 hardware with USB-C on it. Now once the display comes up, the viewable area of the display, I believe, is 24 millimeters square. So, because I think it's a 320 by 320 display. Or maybe, no, it might be 240 by 240. I can't remember. All right. Ooh, I need to make that bigger. The viewable area on this display is actually larger. So that is out to about 27.5 millimeters. I could even go out as far as 28. Nah, I'm going to go for 27. Oh, what if I bring it into 27? It'll slightly cut off the viewable edges. And is it the same this way? Yes, it is. Okay, I'm going to make it 27 by 27. 27 by 27. And the top of it is... is about 6.7. So what we want is 6.7 plus half of 27, which is 13.5. So we want 13.5 plus 6.7, which is 24.2, I think. 24.2. No, I totally screwed that up, didn't I? Hang on, what are we doing? 27. Half of 27 is not, it's not that. It is 13.5. 13.5 plus, see, I'm math good, 13.5 plus 6.7 will take us out to 20.2, give or take, looks about right, 20.2. So I want the center 20.2 off the top, and I want it 27 by 27. Okay, so I need to change the display viewable area.
It's gonna get wonky.
Yeah, I am wonky. Who said it's going to get wonky? Whoever it is, I agree. All right, 27. And that one, 27. And then I want to dimension the center of this off the top edge of the PCB and make it 20.2. Okay. That is going to put us somewhere in the ballpark, I believe. Where can I put these dimensions where they won't be too annoyingly in the way? How about inside the cutout? That'll do. Okay, very nice. And now just because... Oh, excuse me. I'm wondering, this is probably premature. Sorry, what's going through my head is using a construction rectangle to locate the centers of the corner mounting holes. But for the front part, we're going to care, but we're not going to care on this face. But what we will care about is that it is centered around this point, which is the intersection of the X and Y axes. So let's extrude. I think we've got enough here that I can start doing some basic extrusion. Finish. Woo! And we can make some stuff happen. So options. What I can do. No. I need to edit this some more. Edit. Or do I? Okay. I'm going to come back to here and I'm going to talk through my thought process more here. What we're looking at here is the face that is going to be extruded to make the front panel and also make the walls that go back, including these feet. Now there's nothing in the feet. And there was on the previous version. So I've got a couple of options here. I could, and also I want to fill it through here, make this a nice little rounded edge. What I could do is use a scissors tool like this, and I could cut that edge out right there. And that then joins these polygons. And I could fill it that. I could then do another rectangle inside here. So essentially I am shelling the feet, but there's nothing in the feet. They don't matter. So what I can do is just let the 3D printer infill them. I don't see, what I'm trying to figure out is whether there is a reason to make these hollow, and I don't think there is. It would probably save a little bit of material on 3D printing, and that's about it. Could you stick on feet?
Outside the box said, could you stick on feet?
Yeah, I could put little, that's true. I could just make it, okay, this brings up something else. I was thinking about doing a wall mount version of this enclosure. Ooh, Crispian, you are making me rethink all of this, because what I could do is make it a simple rectangular box which does not expose the bottom, and then rely on putting stick-on feet on it if it's going to go on a bench. But that same enclosure could go on a wall. However, the problem is the USB-C connector coming out the back. If it's going to go on a wall, there needs to be some way to get power to it. That is a problem.
Amanda Thompson said, to add some weight in them.
To add some weight in them. Yeah, that's true. It's going to be pretty stable anyway, though, I think. I don't think I'm going to have a problem with the whole thing being wonky because it's deep enough that it's not going to fall front and back. It's going to be quite stable. And Andrew says, or use standoffs to make legs. Yeah, so there are a bunch of options here. There are many different ways I could do this. I think I am going to follow this strategy of trimming this out and then extruding the walls and making the feet solid, essentially solid. But what I will do is, and the other thing is there are a couple of options for filleting. Now, you can fillet in the sketch or you can fillet when you're doing the solid modeling. In the past, I have pretty much always done filleting in the solid model, but these days I'm more inclined to do filleting in the sketch. So the radius I've got on the corner of the PCB, I need to fit around. Where did I put it? Ah, there it is. And why am I looking at that when I can do this? It's right here, people. So there is the corner of the PCB, and you can see that it's got the 2.2mm hole, which is offset 3mm from the corner, and the radius of the corner aligns with the center. So if I do a 3mm radius fillet inside the enclosure, it will perfectly wrap around here. It will go just nicely around the corner of the case. Which reminds me, how about we save AQSV for enclosure? That'll do. So if I, but one thing, are there any fusion gurus out there? Because this is something that annoys me. What I want to be able to do is fillet between these two edges. I'm going to make it a 3mm radius fillet, which will fit around the PCB nicely. I have just done one fillet. I wanted to do it for a bunch of corners. Oh, maybe, can I select just that corner? I want to select that. No, it won't let me. It only lets me select two faces. So, which means...
said you could use some duct tape and cable ties for a less elegant but sturdy solution.
You got to remember the hot glue though. Can't do the thing without the hot glue. And there, and make it 3mm. Okay, so that then does the internal radius inside the enclosure, and I want to do an external radius as well. Now this is an area where if I had done this internal dimension first, I could have then shelled it and it would have ended up with a nice thing. Now, this is where some trickiness comes in with doing a radius, and I'm going to show you what happens if you do this the naive way. So if I now do a fillet on the outer shell between there, and I also make it 3mm, look what happens and how ugly that is. Now you won't actually see this from outside the case, because once it's all enclosed, all you see is the outside radius. But look, we have the 3mm radius on the internal fillet. We've got a 3mm radius on the external fillet. But because this is larger, you can see that where the fillets start is offset. And that gap there, the case gets thicker. Instead of being a consistent 1.2mm all the way around.
As an ADHD crafter, I've got you sorted with the hot glue. If I can find it, that is. Lol.
Yeah, you got to find your hot glue. You got to have a few spare hot glue guns. I've got, no exaggeration, I think I have about 20 hot glue guns, but I've only got 2 that are decent ones that are in regular use. The others were from a class set that I bought many years ago for an Open Hardware mini-conf thing. Anyway, so I think you can see what I mean here about the geometry being wrong. They've got the same radius.
Said, and them googly eyes.
Yes, we need googly eyes. Crispian says you need 2 different radii. Exactly. Because what you can see here with these two dots, that dot is the center line of this radius, this dot is the center line of this radius, and they do not line up. They really need to be, the center of the radius needs to be at the same point, which means the radius needs to be bigger, and it needs to be bigger by the thickness of the side. So instead of being a 3mm radius, it needs to be a 4.2mm radius. So this one right here needs to be 4.2mm. No, wrong one. This one needs to be 4.2mm. I got it wrong. Why is it slightly offset? Ah, that's from there. How did I screw that up? I know I've screwed it up, I'm just not quite sure how. Let's see. It should be, so the distance of that face to that face. Why is that 1.1 millimeters? That's what's weird about this. Are these not? Why is that 1.1? Do I have a rectangle here which is not centered? Those two rectangles should have the same center point. That outer one. Okay, so we've got a distance there to there of 1.11342 millimeters. What is it from there to there? 1.086. It's not symmetrical. Okay, people, why is this not symmetrical? Let's start adding some constraints and locking this down. So this one, there's a whole lot of constraints. Why? What I should have been doing is using the construction lines and anchoring to the construction lines as I was creating those rectangles. Ah, I wonder if there is some other constraint. Okay, just as an experiment, I'm going to add a radius onto this point here. Well, add a fillet and make that 4.2 millimeters. And has that moved the geometry? Because I've noticed that sometimes Fusion will move the geometry. No, it's still 1.086. Okay. We have a screw up here. So what I'm going to do is start again, but I'm going to add some constraints. So let's go for, actually, can I undock this tab? No, I can't. Ah, that's a pity. All right, new design. Here we go. Let's start again. But this time we have a whole lot of stuff for reference, which means we don't need to derive all of these measurements again. But I'm going to try to sketch it in a way that constrains everything. So the very first thing I'm going to do is add some construction lines as references on both the axes, because I'm going to use these axes as my reference points, and I've locked both those lines. Oh, I forgot. Got to make them construction lines. There we go. So they don't affect the geometry when I'm selecting areas and things. Now back to reality. Where was I? Okay, so the first thing I did was the board, which was 58 by 44. Let's add that in again, just as a reference, once again as a construction line, and it was 44 high by 58. Okay, so then we need to do, and what I shall do this time, is it, it's already anchored because of, just by virtue of that one, coincident, constraint, coincident, coincident. Okay, so it's triply coincident. So that rectangle should be locked in place. So let's do another one which is not that. And this one is the one that is what did I do as the offset? I think I made it 0.4 clearance on all sides, didn't I? So I want this to be 44.8 and 58.8. Okay, so this is going to be the inside. Michael says, I'm blaming Imogen for saying googly. Yeah. And then we're going to do another one. And we're going to constrain it to there. Oh, I'm wondering if I should shell this. Should I shell it? Or should I do geometry primitives? I'm going to stick with geometry primitives. For no particular good reason. So I want to go 44.8. No, I just realized I want 1.2 millimeters per side, which is 2.4. So what I should be doing is 0.3 clearance, which takes that to 44.6. 44.6 and 58. Oh, cursor's jumping all over the place. 58.6. Which is probably what I did on the first one anyway. Okay. Hang on, why is my mouse being all jumpy? Strange. Okay. Oh, come on, stop jumping around. There is... Okay, I've got to switch focus away from Fusion and then back again and see if the mouse gets better. Nope, it's jumping around like a crazy thing. All right, on here, on here. So, I want that to be 44.6, 40, 45, 46, 47. So I want that to be 47 and, oh, come on, what was that? Geometry, 58.6, 59, plus 2, 61. Okay, and now let's check that this hasn't screwed up. Oh, come on. I can't even point at things to select it. Here we go, and there. 1.2 millimeters, hooray. And now let's check from there to there. It has to be 1.2 millimeters. Otherwise, we have just discovered a flaw in basic mathematics. So, come on, there, 2, and there. 1.2 millimeters, yes, okay. So we've got ourselves some basic geometry now at least. And hopefully it is all constrained because they are, the center points of those rectangles are all coincident with the construction lines which are on the axes. Let's do AQS, V for enclosure for real this time, final with tweaks. Yes.
Outside the box said, it might be easier to use a lump of clay.
Yeah. Do it the way cars are modelled. Carve it out of clay. All right, what have we got here? 61 by 47 was what I had there. And here I've got 61 by 47. Okay, so my overall geometry is the same, but hopefully this time I have proper constraints. And it'll stay symmetrical. All right, now let's do the thing. Oh, come on. What do I need to do to make my mouse stop jumping around? Distance, and now this time we will do the distance off the construction line. Well, it says 30 millimeters, 30 plus something about 8 decimal places down. So 30, and then let's do non-construction and coincident with that corner, and we'll make it 10. I may well have made this shorter than the previous iteration of the enclosure, but I think that's okay. Yeah, how tall is this? It is only 7 millimeters, Why? Oh, hang on, that's not... Okay, I've got to make that collinear with that. And I have to make that collinear with that. Okay, so now we should have a nice number without any... Yeah, 6.5 millimeters. Without any stupid decimal points there. But let's make this... I'll make it 32 millimeters just to give a bit more airflow underneath here. And now we should be almost back to where we were before, but without all of the weird filleting and stuff. Oh yeah, I've got to do the front window thingamajigamy. So I want that to be 27 by 27, 27 by 27. And what was the offset we calculated from the top? That offset there is 20.2 millimeters. Oh, come on. There. From there to the top of that construction line, which represents the PCB, 20.2 millimeters. Okay. I think we are in better shape now. So now what I can do is start slicing up these primitives, and we'll end up with a compound shape. So now, oh, let's go there and there. What is that giving us? 2 millimeter arc. That'll do. That's a nice little. And there and there, 2 millimeters. I don't really care. That's just like an aesthetic thing. And now, okay, so now we are back to where we were originally. And one thing I've noticed that Fusion does sometimes is if it has dependencies that or constraints that you're not really you're not visualizing properly, or it automatically applies constraints. If you make one change, it can push things elsewhere, and I suspect that's what happened earlier. So if we now have a look at the distance here, it is 1.2 millimeters. And if I now fillet this and this by 3 millimeters, that'll still be 1.2. And if I fillet this and this by 4.2 millimeters, we should now have, yes, we do. We have coincident centers on those two radii. So we've got the radius both from that center point both to this curve and to this curve, which means that the faces of this wall are equidistant as they pass around the corner there. Hooray! Hooray for science! So let's do the same thing here. We'll fillet this one to 3 millimeters to match the PCB. Fillet this one to 4.2 millimeters to match the inner radius plus the thickness of the wall to make them equidistant. Oh, motorbike's just pulling up and leaving again. Where are we at? Where are we at? Oh, that's right. I want to fillet these internal faces, like from there to there, and from. Oh, I wish it would keep the tool. It's probably. I need to set up a shortcut to that radius tool. Okay. Now we are getting somewhere. I think this should be pretty close to what we want. Oh, my space mouse has got intermittent as well. It's, yeah, inputs. Oh, come on, not working smoothly. Maybe I need to quit Fusion and start it again. All right, so what I can do is select this geometry. Do I want to do radiuses under there? I think I do. I think I do. I'm going to go back in and edit the sketch a little bit more. Hang on, what's going on with the the drinking game? Is the drinking game now anytime I say the word equidistant? Oi, what was that? I was just trying to zoom with the trackpad and it went kind of crazy. All right, I want to put little radii on, but just small ones on here and here. What do I want? 2 millimeters. Yeah, 2 is good. There and there. 2, yep. And is it going to remember that I asked for 2 last time? Yeah, 2, good. And 2 and 2. There. Okay. So now back to here. If we do this and this, what I'm going to do is extrude this 1.2 millimeters forwards, and the sketch is then going to disappear. And this is now the front panel of what the enclosure is going to look like. But we also want it to come back. So let's turn that sketch back on so that we can see the geometry. Grab this edge, and I'm going to pull it back by some arbitrary amount, just minus 10 millimeters. And we're going to have to edit that in future. Then I'll turn that sketch back off. We're going to have to edit that in future. Oh, this is so frustrating. I can't like pan and rotate smoothly. That's a bit better. Okay, so now we're looking into the front of the enclosure. But we need to add some features in here. In fact, should I have done it in the last sketch? I probably should have. Okay. Firstly, let's save this, just in case. And I'm going to add standoffs in the corners where it's going to push against the PCB, so the PCB will sit on them, and they will have holes in the middle for screws to go into. Yeah, I think I'm going to go back to my original sketch where I should have done it in the first place and add it into here. So what I can do is add, or is this going to make it all too messy? I don't think it'll make it too messy. Sorry, to explain my thought process. I'm trying to figure out whether to create the geometry for the standoffs in this sketch, or whether I should start a new sketch and do it on the face of the inside face of the enclosure. I think I will do it here so that it is all tied together. So step 1 is going to be, I'm going to create a construction rectangle which is tied to that center point, and the corners of this rectangle are going to define where the holes are in the PCB. So the PCB is, what's the height of it? It was 44, where I'm looking for the geometry. There it is, 44 millimeters, minus a 3 millimeter offset on each side, which is a total of 6. So I need this to be 38 millimeters high, and the width of it was 58, minus the 6 millimeters, so it needs to be 52 millimeters wide. And that's it. So that rectangle, the corners of this rectangle, should now be the location for the screw holes in the PCB. So I can then come in, do a non-construction hole. Oh, come on. All right, I'm going to put it right on the corner of that rectangle, and I'm going to do, actually, let's do this. Let's like pretend to be doing this properly at least. I'm going to add a user-defined parameter. I'm going to call it hole size, and I'll just make it 2 millimeters, because what's going to happen is that if I make a 2 millimeter hole, it'll end up slightly over extruded. The hole will be less than 2 millimeters, and then a 2 millimeter screw should be a just a neat self-cutting fit into it. But it means that later, if I have to reprint this, I can just make that hole size. I can just edit that, and then the hole sizes will all change. Now, next thing I want to do is put, how much clearance do I have around those holes? Did I leave a lot? No, not so much on the sides. The top ones are pretty good, the sides are not. Alright, so for the top, what I can do here is make another circle on that same center point, and I can bring it so that it intersects right there with this side. In fact, what I'll do is I'll take it to that point and snap it there. And I'm not going to explain myself. You will see, whoop, not that. You will see, come on, once I get to that point. So center there, and I want to make that hole size. And then I want to do this, snap it to there, same as on the other side. And then down here, hole size. And I'm going to have to figure out how to handle that. Actually, what I'm going to do, I know what I'm going to do. I'm going to give myself some clearance by cutting into it. I'm going to overshoot that, same as on the top corners, but then I'm going to make it cut out. You'll see, you'll see. It'll be beautiful. Hole size and circle, and take it to there. Yep, to there. Okay, now, what was I talking about earlier with clearances? All right, I'm going to do a rectangle starting from here, and the height of it doesn't matter. Well, actually, what I want to do is make the height, make it coincident with this line, but the width is what matters. I'm doing all this stuff in my head, like I'm trying to juggle a whole lot of things in my head and not explaining it. 48, let's make it 48.5 just to have some clearance. We'll make that 48.5. Once I start carving up the geometry, my madness should start to make sense. And that can be 14.6, yeah, that'll do. No, I want it to be, okay, how about what I do is I just end it at 10, make it 10 millimeters, and then I'm going to change the geometry to make that bottom part of the rectangle coincident with the body there. Aha! You still have no idea what I'm doing, do you? Alright, now, if we make that sketch visible again, this is when the magic happens. Now what I can do is select that, and here's the cute bit, that, and that. And you can see that down in the bottom here, these corners have now been sliced. They've had their edges sliced in. Why did I do that? I hear you ask. That is because the particulate matter sensor sits in the bottom of the enclosure, and it's a rectangle. And the width of it, it's about 58 millimeters, has to come out close to those screw holes. So what this does is provide clearance relief so the particulate matter sensor can sit into this area here in between these standoffs. And let's once again pretend to be doing this properly, and we'll say front standoff distance, and we'll make it, I don't know, 8 millimeters for now. I'm going to actually measure this. The only way to know for sure on this is to measure it. So now I'm going to do a press pull, and I'm going to make it front standoff distance. No, I'm going to make it minus front standoff distance. Minus front standoff distance, so that it comes up. And now we have some little mounting stakes, and I'll turn that sketch back off again. We have some little mounting pillars that the PCB can sit on, and screws can come in from the back panel and go into the holes in the middle of those pillars. It'll go through the PCB and into the pillars. And the pillars have clearance on the bottom. Now we need to do a cutout in this bottom face as well, but that's coming up. We're not quite there yet. But basically now we should have something where we could drop the PCB in there and the screen would align with this hole, and the corners of the PCB would fit neatly into here, and the screw holes should align with these holes. Wagon Loads asked, where is the air intake and outlet? Intake, outtake. Yes, that'll go on the bottom here. It doesn't exist yet. And that is because this extrusion distance is not actually necessarily accurate. I just guessed. I totally made up and just extruded at 10 millimeters, but we need to change that. And this 8 millimeters on these standoffs, totally made it up. So what we need to do now that we have the basic geometry sorted is to look at the real thing and see what those offsets need to be. So, you come with me over here. We're going to come over to the bench over here, and we're going to find out what that offset needs to be. Now what we're talking about here is this distance, oops, where is it? There. This distance here. This is going to go down into the enclosure that we were just looking at. These are going to sit on those standoffs, and the distance from the face of that standoff to the inside of the body needs to come to the front of the display. So essentially the dimension we care about is this dimension right here, which is about 16.8, maybe as much as 17 millimeters. Let's see, if we made it 17, is that going to end up with too much slop? Or is that going to fit okay? Yeah, I think I'll make it 17. 17 should fit nicely. So, hang on, I need to cough properly. I've been talking strangely for ages because I've been needing to cough and I haven't stopped to do it. So the actual depth of the case needs to be significantly more than the 10 that I extruded it. So here we've got, if we took it to, well, if we took it to near the back of the USB-C connector, allowing for the thickness of the back itself, say we took it to 26 millimeters, 26, that seems about right. That'll cover the switch. Oh no, I'm thinking of moving the switch to the front. I really like that idea of moving the switch to the front. So I'm going to disregard that switch, and I'm just going to I'm going to clear this switch. So from there, it needs to be, say, 24 millimeters extruded, and this needs to be 17. So 24 and 17. Let's see if I can remember those numbers long enough to get back to my computer and make the changes. So this extrusion here needs to be 24. No, needs to be minus 24. Edit feature, minus 24. That's better. And this feature here is the one that we configured, so let's modify the parameter and change that to 17. Was it 17? I think it was 17 millimeters. Okay, so now we've got the modified geometry, and that should be about right. Let's just save. Jordan, thank you. And Wagon Low says the far end of the scale is a depth gauge. Yep. To Braze, you made it along. Thank you for coming to Braze. Yeah, so we have here, yeah, we have here an enclosure. That should, it's missing some holes, but that should basically be the correct geometry now to enclose the PCB, have the display in the right place, and have the correct distance front to back, so that when the PCB is resting on these faces, it will be, the display will be against this. So a couple of little things I want to do. One is, oh, I wonder if I should fillet these corners to make the, I kind of feel like I should. I feel like I should. Let's do it. Instead of having sharp edges on this, because the this comes down to this whole thing of, should I do this in the geometry of the sketch, or should I do it when I am just molding this like clay? So I'm going to add a little, come on, where is it? Fillet. I'm going to add a little radii onto here. 2, is that too much? Is it too much? I'm inclined to make it something like 1.2. Yeah, that'll do, just to take some of the sharpness off the edge of it. And then I am going to select this all the way around. I need to be able to, yeah, I should do a chain selection there, but oh well. I've got it anyway. And then I'm going to not fillet it, I am going to chamfer it at, where's the little selection thing? I'm going to chamfer it in this way. Good doink. Come on. Can I grab you? How about I type a number in? 1? 1? Yeah. That's good. 1 is good. Alright, so we've got a little chamfer on the front there. So that will just make the display look a little bit neater, I think. And ultimately I want to chamfer all the way around here, I think. I don't know. Do I want to? What did I do in the last ones? I left them as sharp edges. Yeah, I just left them sharp edged. Which looks okay. That can always be added later. So now, let's do a cutout for the air vent on the bottom. So I'm going to do this with a sketch on this face and just sticking a rectangle in and then punching a hole straight through the bottom. The thing is going to be the position front to back. So if I do a sketch on this face and then I just do, in fact, what I'm going to do is, just to make sure the geometry is definitely forced onto the center line, I'm going to put, and also I'm going to put a reference line on the axis, because that axis is actually the internal face of the enclosure. So that is a useful reference point to have, because we need to measure how far back from that face the vent needs to be. So let's stick a vent just arbitrarily in here somewhere. It is going to be sort of towards the front-ish, but we will set the location later. So we'll set it to be, how big is this vent going to be? I want to expose both the, I could do 2. I am tempted to do, I could just make it a big hole, or I could make it different holes for the different parts of the sensor. Oh, what to do, what to do? I'm going to be lazy and just make it a big hole. I'm going to make it about 16 millimeters by, how wide does it need to be? About 40 by 16. 16 by 40, and that is going to slightly protrude into the edges, but that's okay. We can live with that. We can work with that. So now I need to figure out the front to back position. The center of this needs to be from the front face, just eyeballing it off the thingamajigamy and doing some caliperization. It needs to be about 11 millimeters off the front face. So what I'll do is apply a distance from there to that that line. No. I want to apply a geometry which is that center point to there of 11 millimeters. Go. All right. Now I will, let's make the body go away just so that we can see what we're dealing with here. And I want to round the edges of this before I punch it out through the, oh come on, there, 4 millimeters. Let's make it 2. Yeah, before I punch it out through the body that we've already carved. So I'll make that 2 millimeters, and yeah, I am kind of taking shortcuts here because what I should be doing is doing separate apertures on the bottom of this enclosure for each of the ports, the 3 things: the air inlet, the air outlet, and the air quality sensor. Not the air quality, the enviro sensor. All right, sketch is finished. I'm going to select the sketch, select this area while the body is turned off, and then turn the body back on, because what I'm going to do now is I need to project this in 2 directions. I need to extrude one side, 2 sides. On this side, I'm just going to be lazy and drag it through because I just needed to clear that fillet. And on this side, I will do, yeah, that'll do. Cut. Okay. So now we have a hole in the bottom of the enclosure, and the fillet that came down on this edge right here has been cut away by that, and the thing is rounded. So getting there. Now what I am anticipating here is bridging problems printing this, because my plan is to 3D print this way. This face is going to be down on the build platform, which means that this is going to be a nice long bridge all the way across there. And in fact, the more I think about this, the more inclined I am to put 3 small apertures in this face instead of this one big one. Oh, what to do? Or at least make a bridging sort of thing. No, I think that's going to be an exercise for later. It's already 12 o'clock and we haven't even done the back part of the enclosure or added the button locations and things yet. So just for the fun of it, okay, something I should have done already before I got to this part of the enclosure. Okay, I'm going to get rid of this one now because that was our old attempt with the broken geometry. What I'm going to do is a sanity check. I am going to come in and go new design, and I'm going to call it AQS assembly. Oh, there's already, oh, hang on. I think I can bring it into this one. Oh, this one, which is already open. Okay, so this is an assembly. So what I will do now is go, where this, no, I'll close that, don't need it. This one is fine. I am going to insert the enclosure into the assembly. And why didn't it save? Cancel that. Cancel, don't save. Why did this not save with its body turned on? Oh, okay. I think I saved it. Okay, so now the body is turned on. I'll save. Because when it was being brought into the thing, it was only the sketch that was visible, which we don't want. Let that finish saving, reopen the assembly. And now I'm going to insert the, it's this one, that's why. I was inserting the wrong one. I needed to insert the for real this time. And we will need to spin it 180 degrees and move it a little bit. But what I'm actually going to do is not drag it into position. I'm going to use a joint to move it into position so that its location is dependent on the PCB. I will show you what I mean. So I've brought that body into the assembly and it's not aligned, and I need to make it aligned. So what I'm going to do is go joint, and I want to take that circle right there, which is the screw circle, and I want to move that body so that it is aligned with this circle right here, which is the front face of the screw hole. And there we go, it's now just moved that up into position, and I will say OK, and now it is in that location. It is, you can see the little logo, the symbol in here, that joint symbol. So those two bodies are now locked to each other through that joint because those screw holes line up. And now we can visually just check yes, and yes, all the screw holes line up and it fits. And look, our cutout in the bottom covers the, I need to move it that way a little bit, I think. Yeah, I'm going to move that hole slightly. So for now, let's just save this assembly, and that switch is going to end up on the other side of the PCB. But what we can do is put in a hole for this switch. I just need a hole that aligns with that, a small one, so that you can push it with a pen or something if you need to reset it. And then a backplate can go on with screw holes to go through the PCB and into the front. Alright, so I need to move it away from the front by, I don't know, a couple of millimeters. Let's do that. Yes, I want to edit this sketch. So the geometry here, which is the distance to the front, I'm going to take it from 11 to say 13 millimeters. Okay, finish, save that, and then we can update it in the assembly. And the offset, there, fixed it. So now this hole is will clear the vents on the bottom of the sensor, and this, which is the barometric pressure sensor and humidity sensor, etc., is exposed. So the hole exposes access to the bottom of the PCB, which is the important thing. All right, we almost have ourselves an enclosure. Almost. Crispian said, if you curve the bridge, it'll offer more airflow and 3D print properly. Curve the bridge. Which bridge? That bridge. Ah, I see. Yeah, I could take that in. Yes. 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 I get your point. So what Crispian is saying is, if the enclosure is printed with this orientation, so it's sitting on the print bed, this is the bridge here, which the printer will have to clear. But there is a hole here and a hole here that need to be cleared, and there is this sensor. So this bridge could actually be angled down, like I could bring this down at a 30-degree angle or something, or a 40-degree angle, so that it intersects down on the side here and then goes up, and then from here it goes down here. That way the printer would have something to build on, and there would just be a small bridge in the middle, and it'd probably do a better job of it. I'm not going to do that, because before I print this, what I intend to do is redo this whole aperture. I'm going to do it with 3 small apertures. So there'll be a small aperture here, and then one down here, and then one over here for the 3 things, rather than having this huge open hole on the bottom. But I will do that later, not now. And I could print with supports, but yeah. Okay, so now I'm going to do a little hole for this, because that's easy. I'm wondering if I'm going to get to the point of doing the back plate. I could just keep the stream going. I'm over time now, but I could do the back plate as well. It's not really going to take that long to do the back plate. All right, so there is science to those apertures. There sure is, David. Crispian said, think unlike Minecraft, gravity requires supporting. It does indeed. All right, so now I need to make a hole for this. So that is on which side? It's there. Okay, so I'm going to do a sketch on here, on this face, and this is the sketch that I'm going to use for setting the location of the holes for the 2 buttons. Yeah, I say I should continue, but I can feel my energy fading. Get rid of that so I can get my tools back. And then I want to do, I'm just going to throw a couple of holes in here without any particular location to them. I'll make that one, say, 3 millimeters, that'll do. And this one over here, I'll make it, actually I'll measure this one. What is the diameter of the shaft on the button? I'll make it 4 millimeters. 4. And all right, so they're not in any particular location yet. What I need to do is figure out that location. So if we come back to the PCB, firstly, we can set horizontal offsets. The small one here is at, excuse me. What have we got here? We have a 58 millimeter wide PCB, which means that we have 29 millimeters is the center point, and this is at 48, which means we have 19 millimeters between the center point and that. So 19 millimeters, 19, so if I set a distance of there to there and make that 19 millimeters, whoops, 19, that should set it in the right place. And what's the offset of the other one? It's it may even be the same. 19. So the center point of this is at 10. No, it's not quite the same. So it's 10. Oh no, it is. That is 19 millimeters off the center line. My. See, I even fail at primary school level maths. Off there, so we'll make that 19 millimeters off the center line. So then, where is the PCB from the face? How far? How far is the center of the button from that face of the PCB? It is about 3.45 millimeters. So, where is the face of the PCB? We will figure that out, but for now I'm just going to stick a dimension in there and accept whatever it is that it tells me. And then work this out. So I'm going to finish the sketch. The what was the extrusion here? So from that face to there plus so what I'm looking for here is the distance from this face right there, which is the front face of the PCB, to the center line of the switch. The switch is going to have to come up a bit. Or is it going to come down? Because it's on, which side of the PCB is it on? Oh, it's on the back of the PCB, yeah, so it's above it. So that extrusion is, oops, how far was that? That was 17 millimeters, so it's 17 plus 3.45, so it's 20.45 off the front face. Back to editing that sketch. Come on, where are you? So that offset needs to be 20.45, not 17. 20.45. Boom. And back to here. Oh, come on. What's with the camera? Camera settings, camera, give me orthographic, please. That's better. Orthographic view. All right, so now the position of this. This one is going to be trickier because I'm switching it to the other side of the PCB, and the actual offset off the face is 4 millimeters. So it is PCB face minus 4, which is 13, I believe. 13 millimeters that way. No. Aha, I did the wrong one. I'm going to edit that. I've got to do dimension on that to that. That should be 13 millimeters. Finish. And let's punch out those holes. Press pull, distance to object. There. Cut. Done. All right. Now we'll save that. Update our assembly and see how badly it's screwed up. PCB thickness 2, says Wagon Loads. No, I actually measured it off the other face. So I didn't explain that as I was doing it, but I would, hopefully my logic works. Okay, so ooh, look at this. There's the reset button aligned with its hole. And there is the mode button aligned with its hole in this axis, except offset onto the other side of the PCB. And it should be 4 millimeters from the center line of the shaft to the face of the PCB on which the switch is mounted. So from this top face of the PCB to that shaft is 4 millimeters. And now it should be 4 millimeters from the bottom face of the PCB to that. So that's looking pretty good. I think we're alone now, as someone sang many years ago. Yeah, okay. So now I think that what we can do is, what can we do? Make ourselves a back cover, perhaps. Do we want to keep going? Who can be bothered with Tiffany, that's right, says Dodgy. Tiffany thinks we're alone now. Make coffee, says Pete. Ah, coffee. What I need is iced coffee, because I turned off the aircon in here before starting the stream, and over the last 2 hours and 21 minutes, the temperature has risen appreciably. David says, I want you to keep going, but if you stop now, you have a good clear start point for next weekend. Yeah, the thing is that I really want to wrap this up. Hang on, got a cough again. My goal for this is to finish this today, because I want this off my to-do list. I really want this done. So obviously I'm not going to get this printed on the stream, but at least I can get the design done, and then I can start the print. It can print this afternoon, and then I don't have to do another follow-up to the air quality sensor, except to show the end result. So I think I will keep going. I'm going to do it. Push through. All right, now, how to do this? All right, what I can do is make a back cover that includes the leg sticking down, or it can just cover the back section here. And I'm inclined to do one that just covers the back section and is beveled to close in, or it can fit inside, so that from the front you can't see it at all. Ooh, I kind of like that idea. How much clearance do I have here? I've got enough thickness. I think I've got 1.2 millimeters or so. And if not, I can do a little rebate to allow that to happen. Yes, I think I'm going to make a back cover that fits inside this, so that it ends up flush on the back. Yes. So what is the distance from there to there? 38.6 millimeters. No, distance 5.4 millimeters. Yeah, okay, because that's minus the 1.6 millimeters ish for the PCB. Okay. Okie dokie. Fit inside, the screws hold it in place. Dodgy. Wagon Light says, if you mount the back plate on a wall, you won't be able to use USB. Yeah, that's right. So the USB is generally only used for power. Yeah. At the moment, I'm kind of thinking of the wall mount as being a bridge too far. It's too much for me to solve now. It's something that I've just been thinking generally about maybe solving in the future. But for now, I think it's going to be okay. Dodgy asked, are you worried about dust getting down the buttonholes on the top? No, not really. I don't think that really matters. There's the sensor in the bottom. The air quality sensor here has a fan in it, so it circulates air. I don't think dust settling on here or inside this is going to affect the air quality sensor. If it settles, it won't be picked up, so I think it'll be okay. Jordan says you'll need standoffs on the back plate, but I like the inset back. Yes, exactly. So what I'm visualizing is a rectangle with corners, like rounded corners, that fits neatly inside here, and a standoff in each corner, and the screw hole with a beveled head so that I can use a countersunk 2mm self-tapper going through into the front of the enclosure. That is basically my plan. So, wait, don't do that. I was trying to get to, oh come on, rotate. Why aren't you responding? I'm trying to use the space mouse and it's just not responding. Magnetic power connector. Ooh, now you're talking. Yeah, that would be really cool. That can be a version 4.1. Okay, enough talking. I need to actually finish this. Enough talking from me, that is. You can talk. Ideas. All the ideas are good. Yeah, a magnetic power connector would be really cool. And then, of course, add a little LiPo and power management. And then we could make it so that it can run standalone, but you plug it in to recharge with the magnetic power thing. Stretch goals? No. I am going to ignore that for now. All right, I am going to do... What am I going to do? I'm going to do a sketch on this face. And I'm going to bring camera back to orthographic. I am going to do a center rectangle. Hang on. Why? Oh, what am I doing? This is the assembly. Forget that. I can't edit stuff in the assembly. Okay, here we're going to do a sketch on that face. I wondered why it had gone back in. Hang on, why is this going back into orthographic view? Come on. I mean, back into perspective view. I want orthographic view. All right, so now I want a rectangle off here. I can't remember what the geometry was. Let's edit. Is it this sketch? No, this sketch. Yes, edit this sketch. I should have been keeping records on a post-it note or something. Okay, so what I want is 58.6 by, where's this one? 44.6. 58 by 44. Okay. 58 by 44. Edit sketch. I want to do 44.6 by 58.6. That should give me, maybe I want to add a little bit of clearance. I think I'm going to add some clearance so that it fits inside. So instead of 58.6, I'm going to make it, what will I make it? 58.2. That'll give it 0.4 clearance. It'll be kind of 0.3. Screw it. I'm gonna round down. 44. Yeah, that'll do. Okay, then I need to be able to locate the holes. So I'm going to do a construction rectangle for this purpose, and 38.6 by 52.6, is that no, it's not centered on the hole. It was 38 by 52, so I'll just do 38, 52. That'll give me the center of the holes. Then what do I need? Then I need... Okay, a couple of things. First, I need to fillet these edges by 3. 3, which will bring it in from that other edge. I need the clearance, the clearance angle. Oh, come on. Add a fillet there and there. I'm starting to get quite hungry as well. So if someone could eat something for me, that would be a big help. Make me feel full somehow. And that, and that, and that. 3mm. Okay. Now, I want to, don't do that. I want to zoom in. Hang on, Why is that a construction? What did I just do? That there should not be construction. That is an actual real geometry. And also you'll notice that I've done the thing of I reduced it by, okay, I should work this out. It pulls in from that corner. What I need to do is make the radius slightly bigger. I pulled it in by 0.2. So if I make that radius 3.2, is that going to, hang on, I'm going to say the word. No, 3.2, 3.4, 0.4. Oh, it's moving that. It's not. Oh. I'm going to do a bunch of undos. That point, the center point of that radius is moving. What? Okay. I'm going to back away slowly because this is not actually a problem that I need to solve. There's going to be a little bit of a clearance thing in the middle here. But why is that offset from there? I think the error is actually in the case, not in the back. Oh well, that'll do. It's a cover on the back anyway, so I'm going to... Normally I would totally finick over that, but I'm going to ignore that for now. Because time is getting on, and perfect is the enemy of the good. Or perfect is the enemy of done, whatever the saying is. Okay, so now what I need to do is let's modify parameters again, and we will add one for screw clearance, and I'm going to make it 2.4 millimeters. 2.4, I think that'll do. And then add a non-construction line on that point, and I'm going to make it screw clearance and circle screw clearance. Do it again. Circle. And then I also need to do the standoffs. So how am I going to do that? I need to do it. This is, did I pull it off 3 millimeters? What's the distance from there to there? I think I can just do this as a circle, except for where it intersects. Yeah, I need to do that to there. So that's going to be a 6 millimeter diameter circle. And also I should fill in so that there isn't a sharp inner radius there. So another circle here, and circle there, 6 millimeter, and circle there, 6 millimeter. Okay, now on the bottom I need to do that same thing that I did, or do I? No, I don't. There's plenty of clearance on this because the sensor is on the other side of the PCB. I don't need to do the cutoffs on that bottom section. Yay! All right. So I think that, okay, I've got to do the USB hole clearance. All right. Where does the USB hole clearance go? Why does this keep switching to perspective view instead of orthographic view? All right. Let's give ourselves a USB socket hole, and we'll make it, what do we make it? We'll make it generous, so we'll make it 10 millimeters by 4 millimeters. 10 by 4. 10 by 4, and oops, 4 but its position is now in question. Where is it? Here. It is offset from the edge of the board. It is across 11 and up 7. It's at 11.7, 7.11. 11.7, so we want to do 11.7. I want to take that center to the edge there. That's going to be 11. And that center to the edge there is going to be 7. All right, finish sketch. No, edit sketch again. One more thing. See, it keeps switching back to perspective camera mode, which is strange. I want it to stay in orthographic. I'm going to, what am I going to do? I'm going to fill it there, and what will we make it? 2, it's 4. Yeah, is the end of a USB connector a complete semicircle? I don't think it is. I think it's a little bit less than a semicircle. So let's make it 1.5. 1.5 will do. And the same here and here, 1.5. I wish there was a way to bulk do this. There probably is 1.5. And here, 1.5. Okay. And we've got ourselves a USB cutout. So, what is the distance? Oh, that's right, it was 5.4 millimeters, wasn't it? Okay. Okay, here we go, ladies and gentlemen, boys and girls, pets, and everything else. I'm going to, what am I going to do? I'm going to get rid of that body. I'm going to select that. Yeah, sorry, I was just thinking through the order of operations here, because what I want to do is pull these down by minus 5.4 millimeters and then turn the body back on. Oh, hang on. I want to undo that. That sketch back on. What's going on here? Did it do them as separate bodies? Oh, it did. Okay, there is a flaw in my sequence, but that's okay. I can do that retrospectively, or no. Okay, I'm going to reverse my order of operations here. Undo, 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 so that we're back to the same body. Okay. Now I'm going to select everything except where I want, oh, not that, except where I want the hole to be. And I am going to press pull minus 1.2 millimeters and turn the body back on, make bodies visible again. And then, this is where things are a little bit odd, I am going to select these bits and extrude these down through the existing body. So let's see if this works. Press pull minus 5.4 millimeters, but I don't want it to be a cut, I want it to be a join. So it ends up as a single body. And I think that's it. And turn the sketch back off. Okay. Let's see what happens now if I turn the other body back on. Look at that. We have gap in there for the PCB. Oops. Gap for the PCB that goes in there. We've got room for the buttons. There's room for the USB socket. So let's save this. Oh, hang on. No, before I do that, I want to go ka-choink, because I want to be able to use countersunk 2mm self-tapping screws here. So I'm going to chamfer that by, I don't know, 1.5mm. Yeah, that looks good. 1.5mm. All right, and now I'll save it. And then we should be able to update our assembly and magically have a back on it. And we'll see if the USB socket, it does, look at that. The USB socket comes through the hole. It all aligns. The holes match up, I think. The holes go through, and it's a thing of beauty. Now let's go and look around inside, and going inside the enclosure, that is the bottom of the back cover sitting on top of the PCB. It screws in through there. Now just imagine that that switch was actually on the other side of the PCB. So it'll be on this face of the PCB coming through that hole. I think we might have done it. I think that might be kind of enough. It's not perfect. Could do with some tweaks probably, like fixing the apertures on the bottom here for the sensors. But I think it's kind of okay. Oh, Pete has something to say. Is there enough room between the large button and the corner post? Oh, text-to-speech doesn't seem to be working. I just saw that there were some comments that should have been read out, and they weren't. Error, no message found. I don't know what's going on. I'm just going to reload the portal and see what happens. The TTS portal. Still no Steve or Steph on the silk. Ah, that is true. This was a an old. This project was done a while ago, so where is it? Enclosure. Yeah, there's no Steve on the silk there. The tradition of adding Steve to the silk screen started after this was done. This was ages ago. If you include the bridge with the back cover, then you're going to be able to print it more easily. Yes. Oh, I see. Yes, I see what you mean, Crispian. So Crispian said if I include this bridge as being part of the back cover, then the whole thing would print more easily. Yes, you are correct. However, that would complicate the geometry a little. So, yeah, I appreciate the suggestion, and it does make sense, but I'm not going to do it. What it would mean is bringing this cover out so that it comes down in this area, and basically bonding this bridge into the cover and removing it from this. However, doing that is a little bit of a complication in drawing and modeling it. So yeah, that would work. It would be possibly a nice optimization, but I don't think it's worth the effort of doing that. I think what I'm better off doing is changing, in fact, screw it. I'm going to do it now. Since we are so far through this, I'm going to change the cutout on the bottom here so that there are cutouts in the correct locations instead of just this one big hole. So let's suppress some features. What have we got? This, that, and that. So this was the cutout. I'm going to suppress that feature. And this one was the drawing that 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 cutout was based on. So I'm going to suppress that drawing as well. All right, and now I am going to do a new drawing. So I'm going to do a version that will replace that, that single big hole. And camera, go back to orthographic and stay there. Stay there. Fusion, what is going on with this camera setting? That is really, really annoying. And lock both of those reference lines, and then I want to do some cutouts. I'll do a center rectangle up here somewhere, say 6 by 8 millimeters. That'll do. Don't really care that much. This stuff for this one, so this is going to be the one for the Enviro sensor, and then I'm going to do one down here somewhere. Okay, looking at the bottom of it, what size do I need? I need a hole for the air exhaust on the left, which is going to be about 7 by 14 should do it. So 7 by 14. And then I need one over here somewhere, which will be about 11 by, say 4. 11 by 4. No, that's the 11. That's the 4. That's better. And in terms of offsets from the center, that needs to be at about 14. In fact, they're both, and that one needs to be at about 13. Okay, so I want to do dimension of this one of about 14 millimeters off the center, dimension of this one as about 13 millimeters off the center. Okay, and distance from the front face will be about 6.5 and about 8.5. All right, so that to there, about 6.5, and that to there, about 8.5. That one's on the center line, and from the front face it needs to be centered at about, let's say 20 millimeters. So there to there, about 20. Ooh, there's a very little bridge there, but I think that'll be okay. It will survive. Well, what I could do is make this 5 millimeters instead. That'll make the bridge a bit stronger. Finish. Turn off. I'll turn off all the bodies. Go joink, 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 joink. Not there. That. Okay. Body back on. And then press pull to, I should have, I'll do it in the modeling. I was just thinking I should have done it in the sketch, rounding the edges on those things. Oh no, I will do it in the sketch, because that way it intersects properly with the fillet coming off the legs. Edit sketch. Here we go. Back into perspective view. Against my wishes. What's it giving me? 2 millimeter radius, that'll do. And now it's saying 1. Silly. Alright, 2 millimeter on there. Yep. And 2 millimeter there. Then, how wide was this? Oh, it was 4. So if I do a 2mm, it's just going to turn that into a semicircle on the end, which is actually fine because it is a semicircle on the end of that hole. Can't believe anybody is still hanging in here with me. What are you all doing? Don't you have anything better to do? Go and do something interesting. And this one, I'll give it 1mm. No, I'll make that 2 as well. Go on, go and do something interesting. Can't find the off button. Yeah, apparently I can't either. And here we go. 2mm fillet on there. All right, so now we have, and I'll turn that body back off so we can do drink. Come on, select that, that, and that. Now we can turn the body back on and press pull 2 sides. And because I'm lazy, I'm just going to drag them out to some random distance. And now we have much more manageable bridges. Hooray! Look at that. If we turn it over this way, it's a smiley face, or it's a surprised face with a black eye on one side. It's me. All right, so then I'll turn the other body back on, save this, and then we can update this assembly, turn that back on, update that, and there we go. We can't actually see the alignment on here because that purplish blue body that's in the middle there, that represents the air quality sensor. It's just a block. It doesn't have the real stuff on it to show where the vents and things are. So what this has done is it's exposed the enviro sensor through that little hole, and it'll have exposed these 2 vents. So really the only way I can check this now is to print this case, put it inside, put the thing in the enclosure, and see whether the holes line up. And if they don't, I may need to make some slight adjustments to the offsets and things. But that should be it. I think we're actually at the end, people. Amazing. Amazing. Perplexed face, says Wagon Loads. Yeah, I am perplexed. One raised eyebrow perplexed. We need trackball cam with all this 3D design, yeah. Well, I'm actually using multiple input devices. I'm trackball to move the pointer on my right hand, space mouse on my left hand, that's what's moving the thing around in space at the moment, and keyboard with my left hand for keyboard shortcuts, and trackpad for zooming sometimes and moving stuff around. So that is the trackpad, that is the space mouse, that is the trackball. Yeah, I use all the input devices. Okay, there's nothing much for it now but to print it, which is going to take a while. In fact, let's find out how long it'll take. Get rid of body 2. I want to see how long it's going to take to print. Save as mesh. Yeah, that'll do. PCB. You can see the path here. The last thing I was doing was working on the PCB conveyor. Let's stick it projects, AQS, enclosure, that'll do, in there, and I'm going to call it enclosure body. Okay, then elsewhere. Wait, what happened then? Don't know. Oh, I know. I do know what happened. AQS, enclosure. Here we go. Enclosure body. Let's open this in Prusa Slicer. See what happens. No, I do not want to update Prusa Slicer. Let's just leave it like that. I'm going to go face down there. What am I going to do? Print it ABS? No, let's make it PTG. We'll make it quality. Oh, hang on. 0.2 quality. No supports. Live dangerously. Slice. What's it telling me? 1 hour 44 minutes. That's all right. 1 hour and 44. What I think I would do is print just the body of it without printing the back, because it is very likely that once I print this and I try to put the yeah, you can see the infill there in the feet. If I print this and then try to put the PCB in it, I'm probably going to discover that the apertures here need to be changed a little bit. They might need some tuning of their position. I'm pretty confident on this one, but these two may need to move vertically a little. So what I would do is print this, check the main body fits, make any adjustments, and then print the back cover separately, which wouldn't take all that long. I think that back cover is probably going to take like 20 minutes to print. So it's in round terms, it's basically like a 2-hour print job to do both parts of the enclosure. All right, let's export G-code. In fact, where am I doing this? Not desktop. I'll go for Dropbox. Yeah, I'm doxing myself again. Superhouse. Projects. Where's projects? Projects. AQS. Enclosure. Yeah, that'll do. Save it as that. And then now I'm going to do this. Yeah, I was just printing. So yesterday I actually did a whole lot of work on the PCB conveyor project because that is the critical thing that I need to get done at the moment. AQS updated 2 years ago. Okay, upload. No, not that. I want to upload enclosure body G-code. This. Yeah, so I was just printing PCB sensor stuff. That was the other thing I was thinking of doing today on the stream, was the PCB center. The PCB sensors. What is the printer doing right now? Oh, there is a PCB sensor on it. I'm going to go and take that off. And then, yeah. And then I'm going to start this printing. We are not going to wait, whoops, we're not going to wait 1 hour and 45 minutes on the stream for it to finish, but at least it will be underway. Okay, and print. Beep, beep. Okay. That's the printer complaining about needing a firmware upgrade, which I am refusing to do. Whew. Oh, it's printing in black, which is probably not what I would want to use for this, but that's what's loaded. So that's what the test print is going to be done with. Okay. We'll let that do its thing. Ooh, look at this. Air quality sensor is almost done. Almost done. So close. Oh. Jordan. Oh, some Call It Fun said, before you commit, can you test move that switch? I will update the PCB so the button is moved to the other side. Yes, that is true. In fact, what I could do is, if I do that, I will have some kind of a half clue whether my geometry is correct. So if I come to here and switch this switch to the opposite side, it's going to screw up some track work, but that's okay. we can live with that. We know what is on in the world. So let's mirror, where is its location? Yeah, so let's mirror that switch. There we go. It's now mirrored onto the other side of the PCB. And then it's going to need some rerouting of the tracks. Route that up to there. And this is technically a new version of the, that's kind of screwy. But what I should do is rotate that resistor. But anyway, now if I save that and update the assembly, I'm going to turn off the, oh no, I can't turn off just that body, or can I? Can I turn off the body? Bodies, yes I can. That, okay. So now I will do an update. Hang on, why is it not telling me? Oh, I know why. It's because I've got to push this to 3D. Right. You'd think I've never done this before. Don't know what I'm doing. Alright, so whoa, the PCB changed colour. It went to like a fluoro green. Alright, so that is now the render of the PCB, and you can see the switch is now on the other side. It's now on this side, and if I now update this assembly, the switch should flip to the opposite side. Boom! There it goes. And oh, look at that! Look at that, is perfection. How good is that? It is coming straight out through the hole. Who ever doubted it? Simon said 6-hour live stream today. It's looking like that. And yeah, it does move the mode switch. Previously the mode switch was right at the back. Now it's more sort of centered front to back, which is much more practical. When you push down on it, the force will go straight down through the body, and it'll be less likely to tip over if you're pressing the button on the top of it. So that is so good. What I could have done is put the reset button so that it was a regular reset button with a hole on the back, because that would leave the top looking nice and smooth. So if there is a future revision, I think that's what I would do. You shouldn't ever need the reset button. So if that's accessible on the back, that would be fine. In fact, what I could do is have a vertical reset button just sticking straight out and have it sticking through the back with a little hole. And that would be easy to print, and it would mean the top of the unit would be nice and smooth. It wouldn't have that hole for the reset button on top. But, oh well, we are making progress, folks. That's cool. Does the switch body clear the post? Asked Wagon Loads. Ah, right, that was indeed the question. Yes. Let's really risk this and do a section analysis through, I want to do a cut that way, I think. Hang on, where's bodies? Turn bodies off. I want to do it through that way. Yeah, so I want it off that plane. Turn the bodies back on, drag it this way. Woo, here we go. Where is that body? Ooh, look at that. Oh, we might have a problem there. Look at that, there's a little bit of an intersection, a bit of an interference there. That is so close though. So what I should do is just reduce, yeah, just trim the edge off this. So it'll be interesting to see how that fits in reality. Yeah, if you think there is enough clearance, add some more. Yeah, you can always do with more clearance. Oh, the other thing we can check here with this sectional analysis is clearance on this part back here, where the sensor, right there. See, there is the body of the sensor, and this is the cut that I did. Oh, I didn't leave much. That is quite a snug fit in there. So the sensor is just going to fit between... Yeah, look at that. It is just going to fit between those two standoffs with very, very little clearance. It should work okay though. Yeah. These are the sorts of things that you discover theory and reality when they meet. They don't necessarily agree on what the world should look like. So next thing is I'm just going to print and see how things fit. I'm going to change the switch to the other side of the PCB. I'll unsolder it, clean up the holes, put the switch back in the other side, and I'll see if I have a problem with the clearance of the body onto that standoff, just in that edge right in there. Maybe it'll fit, maybe it won't. It's going to be very close. So I fully expect that I'm going to have to iterate on this case design once I've physically tried to put the PCB in there. I'm going to discover clearance issues. For example, getting this switch in through the hole, the PCB is going to have to go in at an angle. I'm going to have to angle it in so that this top end goes in first. It's going to go in, well, looking from your side, going in that way, so that this top part of the PCB goes in first with the switch going in through the hole, while the bottom side of the PCB is still exposed, including the sensor, which is quite deep. So I have a sneaking suspicion that I'm going to have a clearance problem with getting this into the case. I very strongly think that I'm just not physically going to be able to get it in, but we shall see. And if that's the case, I might have to make some allowances somewhere along the way. Either that or solder it in the case, yeah. Pete, my face is a clearance problem. Yes, my face is a big problem of many, many different types, not just clearance. A security clearance problem. Okay, this is now a 3-hour and 8-minute live stream. Why are there still 53 people watching me? What are you doing? Go away. Go away. Outside the box says use a slot rather than a hole. Yeah, but the thing is that then the slot is visible on the top. I don't want to. I don't want to do a slot. I don't want to. Can't make me. So, Simon said the face definitely had a clearance problem yesterday. Yeah, clearance from Shane's fists. I was trying to stay clear of his fists, I just failed. They move too fast. Okay, I'm going to turn that body back on so that we've got a complete model now with the back enclosure, like the full enclosure in place. And I think I'm going to stop because, oh, Simon says do a weird chamfer on the inside to provide some relief. Yes, that was something I was half thinking about as well. So if we have a look back in here, no, not there, here. And yes, I need to fix the name on this project. What I could do is add a little chamfer on the inside here. So in fact, what I could do is just, I could do an inside chamfer like that, and that would help. it would help with bringing the switch in at an angle and then getting it through that hole. And some kind of a chamfer in here on the bottom face for allowing clearance of the sensor and stuff. But I don't yet know how big of a problem it is. So my first thing is to, this really is the point where the only way to know is to try it. I've got to just print it, try putting the thing in, see if it'll fit, see if the case bends enough. It may well be that the case will deflect enough because I'm printing it in PETG. It'll be a little bit squishy. I might be able to just bend the case slightly and pop the PCB in, never to come back out again. Don't know. So, got to try it and see. At a certain point, things have to become real. Crispian says, I bought the current print for these changes. Oh, and Stephen W says, put a relief on the standoff for the button. Interference fit. Dodgy says, how do you watch a 2-hour live stream? John live stream? Turn up an hour and 20 minutes late. Yep. That's right. No, I don't think I am going to stop the print. I'm going to let the print run because what I am absolutely certain of is that there will be other things I learn. For example, the position of the cutout for the screen. It may be that I have the vertical offset for that off by some small amount, even by 0.5 millimeter or 1 millimeter would be enough to make it look very wrong. So I am sure that there are going to be other things I want to tweak on the design. So I would rather learn about those things and then apply all of those corrections. And then the second one that I print can incorporate these changes all rolled together. And then hopefully, Russell said, I think you need to take the bottom off and put it on the back. Yeah, that would potentially solve that problem. That is basically like a supersized version of what Crispian was suggesting, excuse me, with adding the bridge to the back so that when you take the back off, the bottom of the enclosure is all opened up. So what I would probably need to do is bring in enough of it. So these faces, this gap between this face and this face, this is where the sensor lives. And what I would probably need to do is cut straight down this area here and incorporate that part of it into the lid. But that is a major exercise in terms of going back and rethinking the design a little. Oh, also, there is something in here that I didn't fix. Look at these. See these really, really sharp concave edges? That's nasty. What I really should do is, what I usually do is do the semicircle and then I draw a straight line perpendicular from there to the side. So it ends up basically being a box with a curved edge on it. But the other thing you can do is if I pull a fillet out of here, I can, do that. And that definitely helps. It means that when the printer is running around this edge, it doesn't run into a sharp edge and then change direction. It runs in around here and it follows the radius around there. So what I need to do is add those sorts of shapes. In fact, I'll do that now. I will do it now. Stick that one in there. Stick that in there. And that one there. What do I need down here? That I don't need it on the bottom. Oh yeah, I could do it. I'll do it in here as well because that'll. Or do I? No, I'm going to leave that as a sharp edge just to maximize clearance on the on the sensor. And then I'll select that edge and fill it. Let's bring it out. Can I bring it out 1 millimeter? Yes, I can. There we go. See, that's nicer. Yep. Do it. Yeah, I could sit here and keep tweaking this for ages, but I won't. Wagon load said, can you design it so the PCB slides into the bottom on edge rails, then close the case by screwing on the bottom? Ooh, clever idea. That is a radically different way of looking at this. I probably could. But, yeah, I would really have to go back to rethinking this design. It'd be probably another couple of hours of work to achieve that, because I'd want to go way back to very early in the process and structure this quite differently. It'd probably need to be structured so that it's printed on this face. So it'd print like that, and then come up vertically with the bottom open, because you'd need the two vertical edges for the PCB to slide into. Yeah, I reckon that's definitely a valid way to do it, but I'm going to keep pursuing this current approach for now and just see how it turns out. All right, okay, back to my face being the interference problem. Yeah, I am going to go because I am zonked and hot. The temperature in here is rising. I've got to turn the aircon back on and not talk for a little while, because I have just done 3 hours and 17 minutes of talking. Yeah, sorry, Crispian, the text-to-speech is not working at the moment. I have a feeling that it, I don't know, maybe hit a limit or something. But the good news is we got a case done. I think there's basically some cleanup stuff for me to do, but I think that I am now essentially done. Yeah, Michael says 3 hours 17 minutes. I think Pete exploded 77 minutes ago. Yeah, what I'm going to do is, I am not, unless something radical comes up, I'm not going to do a whole extra live stream about the air quality sensor. I want to consider this to be the last stream about it, except for a quick update, like just showing you the outcome of doing this print. So on a future live stream, I will show you that happening. You can see the printer moving sometimes. There it goes. I will show you what the printer produced and any tweaks that needed to be done. But it's at the stage now where I think I can make some of these and print some cases. So, Crispian. Yeah, Simon says you need a final show and tell. That's right. Yes, a show and tell, just to show the end result of how all of this came out. Crispian said, where can I buy one? And it will be, hang on, I am going to throw back to, it's not, it will be from here. I'm going to drop this into here. So this page has info about previous videos that I did. Oh look, videos coming soon, years and years ago. And I'm going to add some more information to this. So this page, this URL is what's actually on the PCB of the device. and it's referenced in the Git repo. So what I need to do is edit this page, which has not been changed in years, with references maybe to this live stream and to whatever else I need to add to it. And then a link from here. Oh yeah, this is a link to the products. So there's a lot of work to print these cases and then sell them for $6. It's just not worth my time. So I'll do a link from here to the proper version as well. Where are we? Record the print and upload as a basic time lapse. Oh, I should have done that. Yeah, okay. So thank you very much for hanging in here for a 3-hour, 21-minute stream. At least we got somewhere. A little hit of dopamine of pretty much finishing this project. So next week is barbecue week. This whole week is going to be stupidly hot. And I don't stand that. But yeah, and next Sunday is currently going to be like 34 degrees or something. I don't like that. But it is barbecue day, so come along and partake. Hopefully there will be more show and tell progress on the lab to show you, for those of you who have been here before. And bring a friend. David C said, if Sunday is hot, should we delay a week? I don't think so, because it'll just confuse everything. It's too hard to communicate that to everybody. And there are people who may come who heard about it through other avenues, and I can't necessarily tell them come next week. So I'm going to go. You should go too. And I will talk to you all next week. Thank you very much. See ya.